Oh, questions. Some of you had some questions.
36.
Starting with 36. Okay, what was 36?
1 over x plus 2y to the 6th.
Now you could write that as x to the -1. Might not be a bad idea. I don't know if it'd make it easier necessarily, just look different with that fraction in it, but otherwise. Okay, and then what's it 1? What's it 1, Seth? What are the directions?
Expand.
Just to expand, okay? And so you should always simplify it. So one way is if you've got Pascal's triangle sitting in front of you, okay? That gives you all of those coefficients, which is kind of nice. Otherwise, you have to go through here and calculate. This formula will find a certain term for you. So in other words, 6C1 would find, if you did 6C1, that would be 6 factorial over 5 factorial, 1 factorial, right? According to the formula. And of course, this 5 factorial would cancel all of those except the 6 and then the 1, right? And so what does that give you? Well, that gives you this term right here, okay? 6C0 would give you this. 6C1 would give you this. 6C2 will give you the 15. 6C3, okay, on and on and on. Remember, it's NCR, and the expansion for any term is x to the n, x to the n minus r, and then y to the r. Okay, so this number here is the 2 powers added together. Remember, the 2 powers added together is always the same as this. Okay, so if you have something raised to the 6, every term will, when you add the powers, will add up to 6. Now, not when you're completely done. For example, if this had a y squared in it, then that changes what that is, but when you initially set it up. Okay, so the first one to the 4th, then the other one will be to the 2nd. Remember the pattern. So when we talked about expanding this, and then the r, the 1 here, is the power that's on this second thing. But remember, the power on the second thing always starts out 0, then 1, then 2, then 3. Remember the pattern. So if you're on the 6th power, this first thing is going to go 6th power, 5th, 4th, 3rd, 2nd, 1st, and 0. And then the power on the second thing is going to go 0, 1, 2, 3, 4, 5, 6. Okay, so one goes downhill, the other one goes uphill. So one way to start out by expanding this, if you want to, I don't know if this is easier or not, but you're going to have this. The very first one is going to be 1 over x to the 6th, and the next one's going to be 1 over x to the 5th, and the next one's going to be 1 over x to the 4th, and the next one's going to be 1 over x, I'm just leaving myself room, to the 3rd, and the next one's going to be 1 over x to the 2nd, and the next one's going to be 1 over x to the 1st, and then the last term's not going to have any of 1 over x on it. Okay, the 2y is going to be, well, that'd be to the 0 on this first one, then it's going to be 2y to the 1st, so that's what I mean by those adding up to 6. This is going to be 2y to the 2nd, this is going to be 2y to the 3rd, this is going to be 2y to the 4th, and this one's going to be 2y to the 5th, and then the very last one is going to be 2y to the 6th. Okay, that's the pattern. And then what numbers go in front here? 1, 6, 15, 20, 15, 6, and 1. Okay, and then since nothing's negative in this one, they'll all be plus signs. There'll all be plus signs in between. Okay, so I'm not saying you have to write it out that way, but that's a way you can break that apart. So you got the coefficients from Pascal's triangle. You got each term, the 2 terms. Remember, it's a binomial expansion. So every time we do one of these, we're expanding a binomial, 2 terms. So there's a first term, there's a second term. If this is negative, keep that negative with that 2. Okay? And now it's just a matter of simplifying. So if you just want to leave that 1 over x to the 6 like that, I mean, we shouldn't leave it 1 over x in parentheses to the 6. We should do the top to the 6th and the bottom to the 6th. Okay?
So to get those numbers, you just go to the 6th row.
You go to the 6th row. Well, it's really the 7th. This is 1, 2, 3, 4, 5, 6. It's really the 7th row. But the one that has a 6 in it, yeah. I mean, remember, this is, and we had this well, hopefully you wrote down, this was x plus y to the 0 power, this was x plus y to the first power, right? You just go right down the row. And so this row here would be x plus y to the 6th power. That would be the row you would use when you have it raised to the 6th. That's right. Okay. Again, this formula is best when you're trying to find a specific term, which we'll get to in a minute with a problem. When you're trying to find a specific term, then it's nice to use that, because then you don't have to have all of the rows of that with you. Question?
What is this used for? Like, what?
Well,
What are you trying to find? What's the purpose of this?
Well, it's expanding out. I mean, otherwise, if you had to expand, I mean, what I said yesterday, but I don't know, you might have been throwing food around back and forth. I can't remember if you were trying to catch it when I said this, but what I said was there are many times in calculus, there's all kinds of times in calculus when the algebra gets in the way. To be able to do the calculus, it's much easier to write it in a certain form. Okay, so having it in expanded form might be much easier than not. Okay, and the choice of taking it as this times this and doing FOIL a whole bunch of times, this is way faster. That's one reason to do it. Another reason to do it is because it's just a really cool mathematical thing with how Pascal's triangle works, and just appreciating the beauty of mathematics. That might be another valid reason. Okay, I know, we laughed at my math teacher when he told us that too, but, okay, I decided to make it my life's work, so thank you for laughing at my decision of what I made my life's work. I really appreciate that. But anyway, right, I mean, so there's a lot of valid reasons to study it, but what actual application, be more of a mathematical application, which would be an easy way to, again, you got it, quotes around easy, writing all that out seems easy, but it may not seem easy, but it's a lot easier than if you had to write it all the way out, right, and FOIL out a whole bunch of time. Okay, and so anyway, so going through here, now the rest of it's just some work for you guys, right, and so here you got to take that 2 times that 6 and make 12. So this would be 12. Now you could leave that 1 over x, but really it would be 12. Probably the best way to write it would be 12y over x. Now you said easier if we'd have done a negative power, right? If we'd have made this x to the negative 1, then you have to mess with that. So then you have x to the negative 6, right? Because power and power you multiply. Then this would be 12x to the negative 5th, y to the 1st. This one would be 15. Let's see, 2 squared is 4. So what's that? 60. X to the negative 4, y to the 2nd. Does that make sense? I mean, that's what, so to be honest, I think that would be the smart thing, is make that x to the negative 1. Now you have x to the negative 1 to the 5th, power to power, you multiply. So 6 times 2 is 12, x to the negative 5th, y. Here you'd have 2 squared is 4 times 15. This one here you'd have 2 cubed is 8 times a 20, so that'd be 160, x to the negative 3, y to the 3rd, okay? So forth and so on. Okay, finish it up, and that would be the expanded form. Yes?
That's not 39.
Yes, what's 39?
2 times x minus 3 plus 5 times x minus 3 squared.
Okay, and you're supposed to expand it. Now, there'll be a couple ways to do it. Now, again, we get into some things where you go to higher math, or you go into calculus, and so we want to expand this. Now, there'd be 2 ways to do it, really. You could expand this one, and expand this one, Allie, that's what you and I talked about. We could expand each of those separately, and then just combine like terms, okay? So this one would be 2, so let's go ahead and do that. So this one would be 2, and then something once it's expanded, and this would be 5. Now, that's easy. We can just do that one real quick, right? That'd be minus 6x plus 9, right? I mean, that one would just be that right there, okay? But this one, so we'd be down on this row right here, right? So like Kale was asking, right? So this one, we'd be down in this row. So what's that going to be? Well, that's going to be x to the 4th and no 3. And let's keep the negative with the 3. That's going to be plus. Then it's going to be x to the 3rd, and it's going to be negative 3 to the 1st. Now, what I forget? The 4 in front of it, okay? Then we're going to have a 6. And then we're going to have x to the 2nd. I didn't leave myself enough room, but that's okay. And then we're going to have negative 3 to the 2nd. And then we're going to have a 4. and we're going to have a x to the first, and we're going to have a negative 3 to the third, and then we're going to have a 1, and we're going to have no x, and then we're going to have negative 3 to the fourth. Okay, so let's simplify that. So we're going to have 2, we're going to have x to the fourth, we're going to have negative 12 x cubed, we're going to have 9 times 6 is 54 x squared, we're going to have negative 3 cubed is negative 27 times 4 is what, 108? Negative 108 x, and then what is this? Negative 3 to the fourth, 81, positive 81. Okay, and then plus that. Now let's distribute 2x to the fourth minus 24x cubed plus 108x squared minus 216x plus 162 plus 5x squared minus 30x plus 45, right? And when we're all said and done, 2x to the fourth minus 24x cubed, I got 108x squared plus 5x squared is 113x squared. I got negative 216x and negative 30 be negative 246x. 162 and 45 is 207, right? There it is. Okay, so that's expanded out. Now the other thing, I'm not going to go all the way through it. The other thing we could have done here is, what do those two have in common as a common factor? They have how many x minus 3? They have 2x minus 3. So you could take this and go x minus 3 squared, and then you'd be left with what? 2 times x minus 3 squared plus 5. Now I'm not sure this would be easier, to be honest with you, because now what you would get is you could expand this out, you could expand this out, and then you would have two like trinomials times each other. And then you don't have a binomial expansion way to do it, so then you would just have to do distributive property, and at the end you get the same thing. So I'm not sure that would be any better to do that first. Okay? All right, what else? Let's do one where you had to find a certain term with the end in it. That was towards the end there. 45, what was 45? So, and what they said in the directions is they want you to find the nth term, right? So n equals 4 means the fourth term. Now that's different than this end, right? That in those directions, that's different than that end. They said n equals 4. So what they're telling you is they went the fourth term. Well, we would have to write 3 more rows of Pascal's triangle to get down to that, right? And I don't want to do that. I mean, I could, but all that would give me was that coefficient, okay? So the 10th term in there, let's just think about the x. Okay, or let's think about what the y would be on the 10th term. So what is the y on the first one? 0, or no, I'm sorry, what the fourth term? What the fourth term, right? N equals 4. So on the first term, the y is to the 0, then the first, then the third. So the one we're looking for is going to have a y to the third. So what does the x have to be? To the 7th. Okay, and then what number goes in front? We get it from right here. So what are we looking for? What C what are we looking for in this problem to find the fourth term? 10C3. It matches with this number. Remember, this is to find the term x to the n minus r, y to the r. Okay, so y to the r, that number right there, that's what we're looking at. Remember, that starts 0, 1, 2, 3. So we're looking for 10C3. That will give us the fourth term of this number. So if I want to look at these numbers, this right here would be 7C0. This would be 7, if this helps you at all, 7C1. This would be 7C2. This term would be 7C3. Okay, you don't believe me? Let's do it. 7C3, that'd be 7 factorial over 4 factorial, 3 factorial, right? So this 4 factorial would leave me what on top? 7, 6, 5, right? And 3 factorial is what? 3, 2. 3 and 2 cancel 6. What are you left with? 7 times 5? 35, right? So this is 7C0, 7C1, 7C2, 7C3, 7C4, and so forth. Okay? So we want the fourth term of when it adds up to 10, that's 10C3. Okay, so that's going to be 10 factorial, 7 factorial, 3 factorial, right? Following this formula right here. I got my factorial in the wrong place here. N minus R factorial. Okay, so what do we got? Cancel that. That'll leave us 1098 over 3, 2, 1. 3 cancels there, 2 cancels there. What do we get? 120? There you go. That would be the fourth term of this expansion. Okay? Now that was an easier one than maybe 48 was. What was 48?
X minus 10z.
10z
Yep, to the 7.
to the 7. Okay, now, in this one, I do have this row down here. Which term do they want? They want the fourth again? So they want the fourth term. So according to this, 1, 2, 3, 4. So we're going to get 35 as our number, but I'm going to do it anyway. So we just said that would be 7C3, right? If we want the fourth term, okay, that would be 7C3. The 7 comes from here, and then that turns out R. So it goes 0, 1, 2, 3. So the fourth term would be that. Okay, so we just did that, didn't we? 7 factorial over, okay, we just did that right back here. That was 35. Okay, so we're going to put it, so we know we're going to have a 35 in front. We're going to have X to the fourth, right? Because it's going to go 7, then 6, then 5, then 4, the fourth term. And that one is going to be 4, right? It's a coincidence that those match there just because this was 7. And then this one's going to be what? Negative 10z to the third. Because that one's going to go 0, 1, 2, 3. Okay, now we want to clean this up a little bit. That'll be 35. That's x to the fourth. This will be negative 1,000 z cubed. So negative 35,000 x to the fourth z to the third would be the fourth term of that expansion. Okay. All right. So there could be, something like that. The final is going to be mostly, if not all, I've decided for sure if I might add a few non-multiple choice, but it's going to be multiple choice. A lot of them. Okay. So that helps you a little bit. And I'm going to let you use your calculator too. Right. So we're going to do some trig stuff today. Review some trig stuff, but some of those, kind of unit circle memorization kind of things, the calculator can at least help you. Now remember, it's not going to give you answers like 5 or 6 and stuff like that, but it's, whatever. So you'll be able to be able to do some things with that. All right. So here's what I'm going to give you during the final. I'm going to let you have that yellow conic sheet. Okay. You can have that yellow conic sheet. It's the only thing you can have out that we had before. The only other thing I gave you is that little half sheet with the log cosines. So I wrote that up there. And then those terms that were on today's quiz. Okay. Or yesterday's quiz. Okay. I don't know for sure. It'll be at least double a normal quiz.
What about the quadratic formula?
No, not giving you the quadratic formula. And I might just put like 15 of those on there. No. All right. So, all right. Quickly, without your calculator now. Even though on the quiz I'm not gonna let you. I'm giving you a little help down here. See if you can remember. Figure those 3 out right there. Write them down. Certainly will be helpful if you're taking calculus next year to know that. If you're going to take it to college, it'd be really nice to know it. But But 45, 45 is those numbers. Across from the 30s, the smaller side, 1/2 is 0.5, square root of 3 over 2 is 0.866, so 0.5 is smaller than 0.866. Okay, so if you remember those numbers, if you can at least draw your reference angle, so 4 pi thirds, remember 3 pi thirds would be pi, 3 pi thirds would be one more pi third, that'd be 4 pi thirds. So it'd be a pi thirds reference angle, sine is the y, remember cosine's the x, sine is the y. And so sine's a y value, so the y that's across from, that's a 60 degree, right? Pi thirds is 60, so across from the 60 is square root of 3 over 2, and it's negative because you go down. Of course, pi fourths are always easier because they're always square root of 2 over 2. Now, don't forget about tangent, sine over cosine, so you have to do some dividing there. But 7 pi fourths would be just 1 pi fourth short of 2 pi, which is 8 pi fourths. And so that'd be root 2 over 2. Since it's cosine, you want the x, and so that'd be positive over there. Plus, cosine's positive down in this quadrant too, or in this quadrant also. Down here, secant, you're going to do the reciprocal of cosine. So I was just thinking of cosine 8 pi thirds. Well, this is 6 pi thirds here, so you go all the way around. Then you want to go 2 pi thirds, so that would get you over to here. Be 1 pi thirds short of 3 pi thirds, right? So this would be 3 pi thirds, or it'd be 9 pi thirds if you go around. So again, you can think of it that way. So pi thirds, this is cosine we're talking about, so it's the x, so that'd be negative. And so it's the one that's not across from the 60. So it's the 1/2, it's the one adjacent. So negative, okay, reciprocal, that's -2. Okay, how do we come up with that? But obviously on the multiple choice part, if you get a decimal, you're going to need to know, if that's the only way you have of knowing it, you're going to have to be able to know what that is as a fraction in your multiple choice. Okay, so let's we'll just do a quick run through here on some sketchpad stuff, and then I'll let you start working. So if we look at, pull this up here, go through just a couple of these things. So like we were just saying on the unit circle, so starting there, remember cosine is the x. Square root of 3 over 2 is longer, like the x at 0.866, and 1/2 is 0.5. So the ones where you have to go farther out on the x, so these lower angles down here, the ones you have to go farther out on the x, those are going to be the root 3 over 2. Because you're going farther, 0.866, and only up 0.5. And then, of course, 45 is going to be the same, and then 60 is the reverse of those two. And then don't forget your quadrantal, the ones that fall right on the axis, right? Cosine is 0 at pi halves, because cosine is the x value, and sine is the y value. So sine of 90 degrees is 1, because it's the y value. And then, again, the same thing as you go around. Also, some of you were talking about converting there. So if you had 4 pi thirds, that is 240 degrees. Remember how we did that? Pi is 180. Just substitute a 180 into there. 4 times 180 divided by 3. If you're going the other way, if you want to take 240 and put it in terms of pi, you do 180 over pi. You multiply by 180. Oops, other way around. Pi over 180. Okay, so 240 times pi over 180, and you can reduce, whatever. Okay, so we did have that. We did do some of that, converting back and forth between degrees and radians. Okay, then we got into the graphs. We also talked about graphs of sine and cosine. Did a lot about graphs and shifting and all those kind of things. So remember, the sine function starts at the origin, goes up through 2 pi. We always talked about our 4 important marks that we always made, which corresponds to your 4 coordinates. So pi halves was right in here. Pi, 3 pi halves, 2 pi, and those were your 4. And it made 5 marks. Remember, there's always one more mark. You had 4 intervals, I guess you should say, which correspond to your 4 coordinates, or your 4 quadrants. Okay, so that was sine. Cosine looked like that, where it started up here, and then at pi halves, and then at pi, and then at 3 pi halves, and so forth. And then the tangent, the thing about the tangent graph, it had those asymptotes at pi halves. Remember, tangent is sine over cosine, so it's undefined when the bottom is 0. So when cosine is 0, well, that's at 90, and that's at 270, or 3 pi halves. That's when we were just talking about that in the unit circle. When cosine is 0, sine divided by cosine has to be undefined. And so you have that. So you had those graphs. And then we also did some stuff with some identities a little bit. Basically, I'm not going to get into those right now, but sine squared plus cosine squared equals 1 was really the big one, the main one that you really had to think about. And then we had the law of sines. That's not going to be on your sheet, but if you're solving triangles, so if you're given 3 parts of a triangle, which were the ones that law of sines was used for? Remember? Well, a better way might be to think of the ones that law of cosines was used for. Law of cosine was 2 of them, side angle side and side side side. Those were the 2 that law of cosines were used for. Those are the only ones. So angle side angle, angle angle side, and then of course angle side side. Right? If you have 2 angles, well, if you have 2 angles, for sure you want to use law of sines. If you have 2 angles, for sure you want to use law of sines. Now, this is the one where you don't have 2 angles, but you can't use law of cosine, right? You can't because you don't have enough information. So when it's side-side angle, that's when we got into law of sines, and we had the ambiguous case, which we'll talk about here in a minute. But anyway, you could find, as long as you didn't have this, you could find the other triangle, right? And with law of cosines, the only time there could ever potentially be no triangle or 2 triangles was when we got into this. So let's talk about that ambiguous case. And now this is drawn a little backwards from the way we usually draw it. We usually drew our one given angle here, and then we had our swinger, right? This side here was that one. Well, this is just drawn the other way. Now, if you remember what we did, it was this number times the sine of the angle. You took this number times the sine of the angle. Now, do that on your calculator real quick. Take 12 times sine 30. Now, you should know sine 30 is 1/2, so you should be able to just do it again. Everybody grabs their calculator anyway. It's 6, right? So what does that mean? So you get this number, we called it B sine A is what we called it. It was B sine A, but it might not match up with your numbers, so, but we call it B sine A. If you take this times the sine of that, it gives you 6. What's that tell you about that swinger side? If 6 would mean what? If it comes out exactly, if this is exactly 6, what's that mean? There's one triangle. It's a perfect 90-degree, right? And 6 would be the exact height that would make just one triangle. What if it comes out less than 6? Too short, right? So when you do the beat, so when you set up your side-side angle, and you do this times the sine of that, that was one way to check to see if there was more than one triangle or not. If it's less than that number, that swinger side, it's too short. If it's exactly that number, then that means it hits perfectly, and it would swing and wouldn't touch anywhere but right there. And of course, if it's long, which it happens a lot of the time, if it's longer, then what? We got one triangle there, right? And you would go ahead and set up your law of sines, and you would find this angle right here. And then what do you do with that number to get your second triangle? Subtract that from 180. And then that would be this other one. Let's show the second triangle. And then that would be the other one right there. So you take 58.3, subtract it from 180, that gives you the 121.7, and then you use that to find the rest. So you go through and find all the missing pieces with 58.3, and then you find all the missing pieces with the 121.7. But if that's longer than 6 in this case, then that means it could swing out there and give you an acute triangle, if it could swing in, and it could give you that. And of course, what if it's so long? What if it's so long that it's longer than 12? What if it's so long that it's longer than that number? It'll swing out here and give you 1, okay? There will be 1. Where's the second one? Right? When it swings back over to there, it's going to be too long. And so there would not be another one. That's a fault in the way the program works. Okay? That is not a triangle. And the reason you can't use that one is that 30's got to be a part of the triangle. So when it's out over there, 30's outside. Okay? So that's where you think you could have 2, but then that's too long. It's longer than that. And so that was what we got for those triangles. Okay, so that's as much as I'm gonna talk about today with the trig stuff. Okay, above the line, those are all of our trig chapters. Okay, so these are some review problems for you. Okay, better get to work. I would say you want to block Coach Matheson, Jack, for that. Okay? Now, I went ahead and added this next chapter below the line, just thinking, you know, by the end of the period, you get done with all those, you need some extra.
Yeah.
I don't even know log you know all those.
Okay? So chapter 4 was just the different trig values, and I just tried to pick one or two out of each of the different kind of sections as you go through. And then chapter 5 was when we got into the graphing parts of it. Okay, so again, this review, remember, is more about, and I'll probably still check a little bit and give you some points for your effort, but I'm not going to be as picky about every single one being done. So you don't have to get real carried away, especially if it asks you to graph entire things and be real picky if it's multiple choice. You don't have a lot of that. Now, like I said, I might still give you a couple not multiple choice ones where you maybe do draw a graph or something, but it's not going to get real in depth, right? It'd be pretty basic graphs. But we can identify those in a multiple choice as well. Okay, but that's the graphing section, and then this was the law signs, law cosines, triangle solving section. So the first 3 chapters we did were all trig. I'll take a few questions on this tomorrow, but I do want to give you work time. I do want to pass back those quizzes, so I don't want to take a lot of time. I want to give you work time on these. So if you have a number of questions before school, would be a good time, okay, to take care of them. Okay. Now you can always ask during work time also, but. And then, just so you know, then tomorrow will be those pages. Okay? So, that'll be our work time tomorrow.
Wait, how did you code terminal?
Code terminal.
360.
Thank you.
Remember code terminal? So what's code terminal with 30 degrees? 390 or negative 330, right? That would be just going around and then going around again or going around the other way, right? From an angle, code terminal means you add on 360, right? And again, these are all in chapter 4, so go ahead and ask, that's fine, but if you're at home or if you're working on it, you can just have to go back to those sections and kind of look up those things.